Oh, well, good morning, everyone. Trust it was a good night last night. Now, just see how quickly I can do this. So, network performance management and how monitoring helps. Just following on from what Tim said. Yeah, here we go. Why do we do this? Well, simply because we want fast, reliable, stable networks. Fast is good. And we do that well. So we don't really need to waste time talking about that. But things we could do better, or things that really not discussed, is how we monitor underneath, which is power systems, air conditioning, generator, the whole lot. Because, hey, at the end of the day, the ultimate indicator is whether our network works or whether it's dead. And if you really want the way to be told it's dead, yeah, the phone will ring. All your customers say, she's dead. Okay. And it is, as network operators, it's actually your responsibility to keep the network up. So you really, don't blame the facilities manager, because quite often they're just a contractor. And they don't really understand what you do, they understand what they do. So we'll just do the pretty picture. Which what we have is we have a site, a typical POP. And with a POP we have air conditioning, we have a generator, we have security. We even have some other fancy things, like if you've got an antenna, you can change the antennas around. That can be all done using stuff that's you can't do on the net. Okay, you've got a UPS, it's SNMP, cool. What about the generator? I don't know of any generators that have SNMP. So how do you capture those alarms? Well, they've got heaps of dry contacts for a start. They got in the electrical world 4 to 20 milliamp voltage sensing. You could look at the size of the fuel. So you really want to know how much fuel you've got on board and what the burn time is. So if the power goes down, you want to know the generator is going to kick in. So you want to test the generator. So that's your guys' responsibility, not, with the FM. So here we are, a typical RTU unit. I actually go for the Accentria kits, so you can basically one end, you can have dry contact closures, you can have relay outputs, you can have analog, you can also put IP cameras in, so that if someone walks into your site, you'll get a picture, they'll get emailed to you, and you'll get alerted. This is what protects you guys. So that's just what I want to talk about. I think that's 5 minutes. Is there any questions?
So why does this be our problem? How do you contract this to the facility? Why did the network operator do this and not just outsource that CAD?
Yeah, Jamie's asked a good question. Is why is it our problem? Why don't we outsource it? And that's generally how people feel at the moment, is let's pass the responsibility on. Ultimately, who does the customer sees providing the service to them? They see you do it. And you need visibility. A contractor is merely a contractor, they've got other customers. If things go down, you're the ones who are holding the baby. Yeah.
Does it support SNMP v3 and does it support IPv6?
Does it support SNMP v3 and IPv6? Yes. Both. Yes. Yes. Any other questions? Cool. That was that for 5 minutes.
Very good. Yeah, excellent. Thank you. Excellent. Sebastian?
Okay, I have 5 minutes and like 20 slides, so this one is going to be like Geoff Houston speed of presentation. Not as funny though. So NZRF, part of the research role and activity we do is the .NZ zone scan, where we go and check every single .NZ domain name in the register at the moment, in order to go and do DNS tests for configuration correctness and data gathering as well. We have a policy listed on our website about how we do that, where we run it from, and the schedule and some high-level results. We use currently DNS check which is a piece of code from the Swedish register. And now we're going to switch to ZoneMaster, which is a piece of code written between .sc and .fr. Runs monthly, and we have data from August 2013, so we have roughly like 3 years of data so far, which is really interesting. We check if a domain name is broken, name delegation has a mail server, some status about the name servers, DNSSEC deployment. We collect information about servers in general, so web servers, mail servers, DNS servers, in order to analyze topological distribution, geographic distribution, redundancy, etc. We also collect TTL, which is really interesting for trends and change across time, and some other stuff, like market share of cloud mail servers, for example. A few glimpses of data. So this is the high-level domain errors. In red, you see the number of broken delegations, which is in the vicinity of 10%. And you see the number of lame delegations more or less flat, so it doesn't go lower than that. It doesn't improve, but doesn't get worse either. In terms of name server errors, you can see the green line is the percentage of name servers supporting NSID, which is RFC 5001. You can try that one if you're interested in finding out what NSID is. And we see that growth as organic when people start upgrading their name servers. At the same time, you see a decrease on the purple line, which is the name servers with open recursion, and the orange line is the number of servers with open zone transfers. So it's decreasing, and I will bet this is because people upgrade the name servers and use different default configurations. We also have, the list of open recursion and open transfer. So open recursion is not good, but the numbers in the .NZ namespace are quite low. Although this is the number of name servers, we can produce this by how many domain names are affected with this. DNSSEC adoption status, which seems to be a topic here and there. You see there are big jump. There are a couple of big jumps. One is by the govt.nz namespace. They sign most of the names, and also the other one is Cloudflare. But there's a discrepancy here. So there's a difference between the number of signed domain names, which is a blue line, so roughly 1,000 of them, and the number of signed delegations, so DS records in the register, which is 750. And that gap doesn't close. So there's a lot of people, there's a few people trying DNSSEC, but they don't finalize the deployment. Why? We think might be the reason might be registrars not supporting DS records. We can talk about that. Anyway, we also collect information about the DNS key algorithms used in the domain names, and you can see the big purple jump is due to govt.nz, and you can see the red one, which is ECDSA, one of the favorite Geoff topics, and that comes mostly from Cloudflare. So actually, 100% from Cloudflare. So they start offering DNSSEC inline for free, and people start using it. IPv4, which is always a topic. We collect how many domain names have IPv4 web servers, mail servers, and name servers. And you see this goes up and down. IPv6 is actually more interesting. So the green line is name servers. So this jump from 15 to 26% is basically one registrar deciding, oh, I'm going to add IPv6 addresses to my name servers. Boom, one go. And then mail servers. Oh, another registrar decided, oh, yeah, I'm going to put IPv6 addresses into mail server, and you have one jump. But other than that, you don't see any growth in this. So it's like, yeah, it's 1 or 2 events, nothing more than that. This one is interesting. I love it. It's the distribution of TTLs for MX records, NS records, web on, so A addresses for www and quad A addresses for www. So the funny one, this is actually not explaining this plot, but doing the change. So this is January 2017, and this is October 2013. So you can see the number of domain names with lower TTLs, especially for web, increases greatly. So it goes under 10% and goes 12, 13%. And also the higher values of TTLs are decreasing. I'm going to leave the slide so you can actually go and take a look. So to finalize, we keep all this data. We publish this data. We have a project called the Internet Data Portal where we publish statistics about the register and on the information we collect about the internet in New Zealand and some other stuff. So you can go and get the data there. It's freely available. And we are working on having a better and solid .NZ namespace. So hopefully you too. So you can use these metrics, or you can ask questions to us also, how I'm doing. We had a conversation, for example, some point with DIA. We provide them with a report of DNS errors for the namespace, and it was like, oh, we shouldn't be doing that. So we can do that for you. And that's it. Thank you.
Right, hi everyone, I'm Brad and I'm representing a group formerly known as Team SDN, but vendors have kind of taken that term and run with it, and it means various different things. So now we've taken a word cyber that everyone clearly knows the definition of, and we're the Cyber Networking Committee. And I'm here to admit to running this entire conference network on Python and OpenVSwitch and OpenFlow. So it started at the end, sometime in December, where we proposed to the NZNOG committee that we'd like to run our research SDN controller as the network for NZNOG, and the reply back was, sure, why not? So thanks. Thanks to the NZNOG committee for that one, and yeah, obviously they loved that they could shift all liability to us. So we just wanted to say a big, huge thanks, because it's really hard to get people to trust your software that hasn't been deployed in large networks, trying to get production time there. So it's a real help for us because we've learned a lot and we've made a lot of commits back to our code base to improve our code for future events. So basically we started like any other network build. We set out a list of requirements. So Vibe had already established some dark fiber into the hotel, and they were already willing to provide all the connectivity. So that's the BGP and the UFB connectivity part. You guys like V6, so we thought, yeah, we better do V6. And then that leads into, we've got to do some DHCP to give out some addresses, some RAs, some DHCP v6 and stuff like that. We thought, you know, we better do DNSSEC. There was so there's Unbound in the network for that. We thought BCP38, since there was a spoofer talk yesterday, and in fact spoofer has been running on that network for the last couple of weeks to make sure my policies work there. And my least favorite part of the project, which has been deploying the Wi-Fi. So it all started with a diagram, care of Perry Laurier. And it's changed a little bit from this, but that's basically the idea, right? We want to take internet and we want to run it through some Linux and put it through Faucet, which is our controller, and then it goes wireless. So Faucet, it's a open source Python network controller. It's written in Ryu. It's developed by primarily a bunch of us in New Zealand. So like WAND, Waikato University, RIANZ, Victoria University, that kind of thing. It does OpenFlow 1.3, it's a central controller, it does switching, it does learning, and it does, we've just added routing, and those are all the features we're using. And it does like VLANs, ACLs, BGP. You can offload various parts of traffic to a Linux box for acceleration and stuff like that, and it's on GitHub. So it started, we worked a little bit and made a more complicated diagram. You don't have to read this, it's just for the history. And this is basically what we ended up building. So there was originally going to be a V6 only network, and that was working on the first day, but we did have some slight issues with some traffic storms between the two halves of the network. So basically what we've got here is two open vSwitch bridges at the bottom of the machine, and that physically gets bridged onto Intel NICs with DPDK. And Open vSwitch is basically entirely running in user space because we can use DPDK to accelerate that. Basically what we had before is we had a Linux VM that bridged the two v6 and the v4 only network, and that was doing NAT64 and stuff. That's all still there, but I've turned it off on the Wi-Fi just because we had that issue. But we think we know how to fix that now, so next time we can fix that. And basically, there's a bunch of VMs for monitoring and for providing services on the network, and they just plug into the bridges using vhost user ports, which are quite fast. And then obviously we just plug the internet in and everything works. So the bridge called BRNZ-NOG, that is doing all our routing, that has a fib table, and that comes from BGP and from Faucet. And then basically we take that and we plug it into switches, and Allied Telesis are great. We love Allied Telesis. They do OpenFlow, and it tends to work really well. So basically all the APs plug into AT switches, and then we just do a VLAN trunk and an OpenFlow circuit back to the Linux machine. I built all of this in Ansible as well, just to make my life a bit easier. There's a lot of moving parts to make this network work. There's a bunch of VMs, and they all need the right software in there. So basically, every network function is an Ansible role, and so you just have a file and say, this machine does DHCP, this machine does DNS, this machine does blah, and then when you change the config file, you just do a push, and that rolls the network out. It's also all on GitHub, so you can see my changes, my little fixes during tea breaks and stuff like that, and you can see the last couple of weeks of work on making all this work. We can also technically take pull requests on this network, so you could come here, you could see a config file is not quite right, or we're doing something slightly wrong, send a pull request, and then I just do a push to the machine. And if you fully trust what's coming from Git, or if you had some kind of continuous integration system or some way of testing what configs are there, you could actually auto-deploy this sort of stuff. You could have a pipeline where you've got your employees writing to Git, you've got some code review, that goes onto a branch and then goes through a continuous integration test system, and then that could auto-deploy if you wanted to scale this a little bit more. And I'll probably look into doing that at some point because it shouldn't be too hard to get working. So because you're all network engineers, I thought it would be good to test this a lot. So basically, I came up with quite a few different test regimes. So I basically just used regular iPerf to test how much load could go through the network. And through OVS DPDK, with me spending about 2 days fine-tuning that, we can do about 6 gigabit per second of TCP, which I think was enough for the gigabit connection that comes into the hotel. And basically I spun up a bunch of Dockers to test Mac and fib learning, and that's on GitHub as well. I really like GitHub. All my work's basically there. And basically what we did is we found what bottlenecks were in Faucet, we optimized those, and we went through the testing regime again until we got to what we were happy with. So scaling and performance were what we spend a lot of time on. So one of our biggest problems we found was v6 is different to v4. So in v4 world, we do passive learning where we can, because for us it's very expensive to go from the switch into our controller software, because we're Python, we don't handle our threading model. This framework called Ryu handles our threading model for us. So it's very expensive every time a packet hits us. So we try and do passive learning wherever it's possible. So what we do for v4 is when a packet, when you resolve your next hop, your gateway, because we hand that out with DHCP, we just take one of those packets off. We learn you, put you in a host fib table, and we learn your MAC. And that all works fine. In v4 and v6 world, you can't really do this because you have a thing called privacy extensions. So basically, at any point in any time, a machine can randomly generate its own IP address. It sends one packet onto the network for DAD, and that's all you see. So if you miss that DAD packet, you could basically never see a further packet from that IP, but the machine's willing to talk on that. And there are a bunch of host stack implementations where you'll use multiple privacy extensions for various things. So Android, for example, will use a different address for doing DNS to regular traffic to the internet, so you have to be very careful to learn all of these. And so basically what we do is we have a technique where we shunt some amount of traffic from unknown hosts from trusted ports on the network up to the controller, where we can learn the privacy extension address. All of this is monitored with Grafana. So Faucet has a module called Gauge, which lets you view real-time statistics. So basically on my laptop, I've got a bunch of graphs of traffic over time. So this is the stats from the main OVS bridge. As you can see, we're doing about, so this is the entire traffic from yesterday. So this peaks up to about 800 megabit. So some reflections. So our experimental L3, it works enough. It does need some additional thought to make this stuff work better, but it works enough. Tests are fantastic. There were many late nights of me and Josh fixing some of our bottlenecks in our learning code, and basically you write a fix, you run the test suite that comes with Faucet, and you realize you made a mistake, and before you deploy, you go fix what you messed up. And another thing, there's no substitute for large quantities of real traffic. So my synthesized traffic was enough to find some problems, but we've found other problems throughout the conference that we'll go back and fix when we get back to the office. And finally, a huge thanks to a number of people. It wasn't just us three. There are some very large email threads, and I apologize if you're on those, for organizing all the logistics with the hotel, for organizing the BGP pairing, for organizing various things. Huge shout out to the Open vSwitch guys, including Joe, who I know are watching on the live stream. And the live stream is going over the network as well, which is quite cool. So Open vSwitch and DPDK mostly just works now. We're running OVS 2.6, and they handhold you a lot, because DPDK can be pretty tricky to set up to get all your packets to the right CPU thread, right NUMA node that corresponds to where your NICs are, and they mostly do all that for you. A huge thanks to Allied Telesis, who sponsored switching, Go Wireless, who sponsored all our wireless equipment. The internet came from Vibe, yeah, thanks to you guys for using the network and providing some data points for us. This whole network is on GitHub, so other people could, in theory, use this network if you want. So that top link is the overall architecture and description of how things work, and then there's the Ansible repo linked off that. There's Faucet mailing list for getting in touch with us if you're interested. And please find me during the breaks if you want to see any of the extended statistics or see the flow tables or anything. I'm happy to show that off. But any questions?
So you all got that? Okay.
Obviously, it would have been better if I could have done a longer talk, but we all got this organized after the call for paper. Cool. All right, thank you.
As an intro to this, I do a lot of network monitoring and management. I teach network monitoring and management, and yeah, it's a great thing if you're a service provider and you've got the infrastructure and you're monitoring your own infrastructure. What if you have outsourced your network? What if you don't control the network, yet you still need good statistics on it? What if that network is Wi-Fi? What if that network is not only Wi-Fi, it has a shitty captive portal on it that you have to log into all of the time to keep going? I ran into a startup based in South Africa that had a really neat product. It didn't work. We had some conference calls. They moved to San Francisco. They got VC. They got a whole bunch of staff. It mostly works now. It's not quite commercial yet, but I have a piece of hardware that they ship out. I stuck it behind the curtains at the back of the room. I gave it the SSID for this Wi-Fi, and it started doing a lot of tests. I also have one of these in a metro area network situation where it logs in via captive portal. Now this is hard. How do you log in via captive portal? The thing also has a cellular modem in it with a global SIM card in it. So they shipped a unit out to me, and I configured it not via plugging into it. I just plugged it in and ran. I configured it via a web portal. And they, in their infinite wisdom, got their South African hackers to write some scripts to log into the captive portal. And they do this as a service. So it is Wi-Fi monitoring as a service, or will be. And I'm going to log in and show how this network performed and some of the neat things. Yeah, maybe. Like my password there?
It's nice and short.
I know. I've never had to type it in before.
This might take the whole 5 minutes. It's about 128 characters long. And that's time. Yeah.
Would you like to remember this password? You really have that set up? Yeah, hey, it works. Not now. Oh, good. Fantastic. Okay. So, what I might do is show you.
Microphone.
What I might do is show you who these people are first. Cape Networks, and their mission in life is to monitor Wi-Fi networks. And should I be closer? And that's the little box that they've got, and it is about that size. And it's very, very simple. You get a dashboard, which I'll show you in a sec. It comes with a nice mounting kit to hang it on the wall. And it just does its thing. And they really have a nice group of people who really care about what they're doing. So here's the dashboard. I have logged in. I've got 3 probes. One of them is on NZNOG conference. Yesterday, there were a whole bunch of little orange blips through this thing. We've got some details about the network. We've got the status and the alerts. It is all running really good. If you're in a situation like yesterday where there was a lot of movement in the room and a lot of hopping between access points, you're actually going to see this graph change where it says band, or you might see the channel change. You might see a bunch of different lines here. I'll try and find that on another graph, and shows you what you're on and what you're doing. We can see here that our DHCP response time has been really good, except for when everybody turned up this morning. We got up to about 8 seconds for a DHCP response. We also have DNS lookup time here, and at the moment that is also good, except for, a couple hours ago we got up to 400 milliseconds. These are really important things for customer experience. So you have Wi-Fi in a hospital, you have Wi-Fi in a city. These are the things that you, as the person paying for, the organization paying for the Wi-Fi, really, really want to know about. So let's go to a real world situation where we have gone and put this in. And here we go with a big production Wi-Fi network. And we have some situations where, what are the reds all about there? No connectivity past gateway. Latency 1.7 seconds, average over 5 minutes. So yeah, that's kind of harsh. We have some low signal problems here. We've got the bit rate that we're connected at, 60, 59, 60, up to 122. Just about 2 weeks ago, this was sitting more around 200 megabit per second. So something has gone wrong on the RF end out at this location. DHCP response time, quite a bit different. And then here, I thought I'd show you latency, packet loss and jitter graphs. You've got an average here, but if you click on this, you've got a whole set of targets. If you click, there we go, and you can put those targets in. So I put in Westpac, Stats New Zealand, YouTube, Vodafone, Dropbox, Google Drive, things like that. And right now there is a Dropbox file that's being downloaded every 15 minutes or so, and we're getting a throughput test there. So neat little tool. You can also do things like configure internal targets. So if you want to separate the performance of the Wi-Fi from the performance of your internet connection in general, you can do IPRFY things too. So this is Cape Networks, and they do have a buy now button because I think their investors have told them to do it. You get 3 units for $200 a month. They do all sorts of setup for you. If you want to start doing captive portal stuff and get them to do the configuration, they want more money. But you also get 15 sensors for that. So I don't think that when you click this buy now button, anything happens. I mean, I think that they say, hey, we're going to call you back, okay? But they are fantastic, and the whole team has been helping out with development and issues on this thing. So I think it's going to be a really good thing. Thanks for that. Can I actually log out? Hey, look, there's a log out button. Oh, yeah. Here we go.
Excellent. He didn't wait for questions. He's out of here.